Hey, hello guys. So in this video, we are going to discuss the design LLD Paytm. Or let's go through the features. Which, by the way, this has been also which we are transaction the operations. They can the next requirement is we need to make sure that we are allowed current to make sure that we are able. So let's say for example, the money was debited from that case those transactions to be reversed, refund, all those things that we are covering. Transaction should be reliable, like when you try to click on let's say pay button multiple time, it should not be is get converted the two payments, so retries are not causing the double trans. We have another thing which is the transaction history, so user should be able to check out their transaction histories. So user should be able to check out the mini statement. For example, right now you can go into your bank app and transact. They should be able to do. These are the these are the features which we need to support. Now let's see what are the approaches, things which we are planning to use. So one of the thing is the strategy pattern which we are. Why? The mode of the payment can be multiple. You can pay from the UPI, you can pay from the net back. Even when you are let's say paying from the phone pay or Paytm anyway, you are allowed to use multiple kind of the funding sources. Can be the UPI card or net banking. So but the operations are same basic. What kind of, I mean, the high level operations are same, like removing the money from your account, adding the money. So but they may have different implementation for the different kind of payment method. Okay, so that's why we are planning to use a strategy pattern here, so we can have the same method for all the operations: add money, deduct money, transfer money, whatever. And we can just do it for the all kind of the all kind of the sources. It can be UPI or other. Why not adapter? Adapter could have been used if we were kind of working with the legacy code, where we are already having the existing code and we really need to support it, or we are looking to integrate with the third party. Right now we are not focusing on that. The here in this design we are mostly focusing on what we need to implement. We are not looking for the actual implementation, which where you may have to integrate the other services, and there you may have to use adapter pattern. But for now, for our use case, the strategy is going to be fine. Why not bridge? I mean, so if you have read about the bridge pattern, it will abstract, basically it will separate the abstraction from the implementation. So the implementation will be written differently and the abstraction will be different. That may not be required here. It can do it, but it is still a overkill. um Seeing that we are already having the payment and the implementation separately. The next thing is template method pattern. Why we are doing it? So but whenever you are doing the payment, let's say you click on hey pay now, there are multiple operations which are running. It's a kind of an entire flow which is running in the backend. First they verify whether your account have the enough balance, or then they verify whether the debits transactions are allowed to your account or not. Then they check whether the credit account is kind correct, or and then basically all the notifications. So it has the entire flow basically. So that flow needs to be supported. If you have gone through the rate limiter blog and that video which we have attached to that, it will be very easier for you to understand why the template method is really kind of a good one. So by using the template method pattern, we can make multiple methods and the flow static. There can be few methods which can be implemented differently if you want. I mean, there can be few methods we have written. Some of the steps could be deferred, like refund or transfer logic. Tomorrow if you want to change the implementation, it would be very easy. Just we need to just make sure that the flow is going to remain same. So this is based on the assumptions that few of the flow is going to remain same and we may not need to change it. That's why we are using the template method pattern, and some of the functions we can leave as it is, and it can be implemented separately if we really want to change one of or few of our steps which we have already loosely coupled from the beginning. Why not use chain of the responsibility principle? As I have said, our transaction flow is more strict. It's not completely strict. Few of the steps can be implemented differently, but the flow is mostly strict. Like, it's not like you need to create the chaining. You don't need to create the configuration multiple time. Hey, do this. There are like certain flows which are never going to change. Like when you're doing the transaction, we debit, credit, and balancing and all that thing, and updating the status in the database. That's why we are not going with the chain of the response principle. Command pattern. Here, I mean, it will here. These are the more of a flow. Um, we don't need the undo commands here because that will be handled separately. But yeah, I think even the command pattern can be implemented. But looking at the entire design, how we have coupled it, template method pattern, I would suggest you to go through the rate limiter. That would give you landing template method pattern. Factory pattern. Um, Here we are just using this to create the objects. It can be add money or the payment object. So nothing much to be discussed here. The next thing is the observer pattern which we are using. So let's say whenever a transaction is going to happen, we need to notify the user. The same this step was also integrated into the template method. See here, we will do the notify. This is how it get coupled with the observer. So whenever the payment flow gets got completed, or either it got failed, we are going to notify our why not using the mediator? We do not want to centralize the object, like, like we in one to many. This way it would be too much. Currently we are not designing the distributed system for. Same goes for the would be a distributed software. For mediator would be centralizing every application between. Here we do not want the coordinator because the chances are state pattern, as we were discussing, that there can be multiple states, the transaction pending, everything have a specific here when we can. It would be better state pattern. Why not strategy? I think where it's just there's a certain limit, but you cannot attach the behavior with the. Tomorrow we want to extend new states or attach the behavior, we would find it very hard. Here when I mean that, hey, when to change from the status to the field, when to change success. Singleton, definitely this is a very obvious thing. We need to make sure that we are only having one transaction manager, single source of truth, so that we are not allowing the users to do the multiple transactions. Let's say if a user was having 50 rupees and we are the transaction 75 rupees because we were having multiple managers and they were not synchronized. So here we are going to use a singleton pattern to have a single transaction manager, which is going to be the single source of truth. All the transactions needs to go through this because this is going to tell us whether the user has enough to do the transaction. And there are other challenges which may have to currency challenge. What if there are two concurrent debits happen to the account? How we are going? Are we going talking? Yeah, other deadlock avoidance. This is more based on how you are implementing the first risk. It like when one person is sending the money to the another person, are you locking both the persons in that way? If the other person, if one is sending the money to two and two is sending, is the kind of a transaction, full transaction happening, and your locking is kind of blocking both of the objects or both of the users, it may lead into the deadlock transaction. This thing we have already also discussed in our bank transaction blog. I would suggest to go through it. Atomicity here, we mean that whatever operations we are doing, it should be consistent and it should be complete. For example, uh, when you are making any transaction, to make a transaction, a debit plus credit both needs to be happen. Either they both happen or nothing happen. It should not be the inconsistent state, a middle of the states. Hey, debit is, credit is not done, and that inconsistent. Let's say wallets, making sure that the balances are correctly. We are always seeing the correct balance. So all these concurrency choices and algorithms we are and the code we are discussing, hey, how concurrencies, how the code look like. Similarly, we will be going into the deeper about all these patterns, what other combinations